The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. Welcome to our first ever CED Greentech webinar training here. I'll be your host today. My name is Christian Bruno. We have a host of different presenters for you guys, different manufacturers. First up, we have SolarEdge and Cameron Stewart. But before we get started there, let's go over some of the ground rules here. If you're interested in placing a question, you'll notice down in the little control panel here for GoToWebinar, there is a questions box. Feel free to type it in there. I'll be fielding all of those and I'll be passing them out to our different presenters. And they will field them and at the right moment. If they have a time to pause during the presentation, they will. If not, they'll answer all of those at the end. But after each segment, there is a 15-minute window for questions to be answered. So don't feel bad if it doesn't get answered immediately. It will be seen and it will be addressed at the end, at the latest. Without further ado, I'll pass this over to Cameron to get started, and thank you for joining us.
Thank you so much. Super happy to be here, Christian. Again, my name is Cameron Stewart. I'm a applications engineer here at SolarEdge. I've been in the solar industry for 15 or 16 years now, working for SolarEdge for the last 5.5. Today, I'm going to be presenting on our backup interface in our Energy Hub inverter. And I just want to make sure, Christian, you can see my screen.
Yes, looks good.
Fantastic. Okay. So SolarEdge, we're at it again. We're releasing a new storage product, and we're going to go through some of the basics. We're going to talk about the new inverter, all the functions and features and capabilities, and then we're going to talk about our backup interface. There's a lot to cover, so I'm just going to go ahead and dive in. And as Christian said, just go ahead and throw those questions into the chat box, and I'll get to them at the end as soon as I can. All right, let's do this. So first I'm going to talk a little bit about SolarEdge, then we're going to get into the meat and potatoes of the presentation, and then we're going to go through the product, okay? So first, if you didn't know who SolarEdge is, well, we're the #1 inverter company, so hopefully you've heard of us. We've shipped almost 50 million power optimizers to date. We have 1.4 million systems monitored on our website, 16.2 gigawatts of systems shipped worldwide, and we're a company of engineers. We have 348 patents with an additional 266 patent applications. So we're always striving to be better than we are, and we're always trying to do that through engineering excellence. So what is smart energy, and what do we think smart energy is? SolarEdge is really trying to shift our view of smart devices. So we developed an inverter that we call the Energy Hub. And Energy Hub is our HD wave inverter chassis, but it also becomes a central access point for smart energy devices, such as whole home batteries, such as EV chargers, hot water heaters, outlets, relays. And we really want to change the perception of how people view smart energy devices. And we're going to start to see the industry go through a paradigm shift of what it is to be an inverter. So we've had legacy inverters, and legacy inverters are just solar inverters or maybe just battery inverters. All they do is one function. And we want to pack more functionality and capability into the Energy Hub inverter. So sure, you could use it as just a PV inverter. There's no reason you couldn't use it as a PV inverter. But then it gives you this ability to upgrade. And after the fact, after you install it, if your customer says to you, I want to install a battery, I want an EV charger, I want a smart hot water heater, it's got all those capabilities baked into it. So the upgrade path becomes instantly easier because you're not worried about running another 2-pole breaker to the main panel. Everything is connected through the Energy Hub inverter. So we have a lot of new devices that we'll be launching over the next year. Some are already released in the rest of the world. We're just waiting to bring them to North America. And then of course, we've changing our suites of software tools to help homeowners and installers kind of organize and view these products. So here it is. It's the new Energy Hub inverter, and it can connect to batteries, it can connect to our EV, you know, depending on your use case application, we can connect generators to it. And what I really want to impress upon you is just the upgrade path capability. You don't have to install all of these things at once. You can choose to install them later after the installation. Now, I'm an advocate for getting the installation done with 100% of the things on day one, because anytime we have to go back to an installation, that's more soft costs, that's more truck rolls, that's more fees. And so I'm a big advocate for, if you're going to install batteries day one. Same rules still apply, but you have the ability to do that. So the Energy Hub inverter is now orderable through CED. You can get it in the 3, the 3.8, the 5, the 6, and the 7.6. Later this year, you'll see the larger Energy Hub inverters come out, the 10 and the 11.4. So all Energy Hub inverters have a built-in revenue grade meter. And with our new product, the revenue grade meter also has capability of being a consumption meter. So if you want to use the standard inverter with nothing else connected to it, you could add 2 CTs and then get whole home consumption monitoring. So you can make more educated decisions, or the homeowner can make more educated decisions about their energy, how they're using it, when they inevitably, when they install that hot tub and they start to use more power and more energy, you can have that conversation with them, because I would always get that call, 3 months after the installation. Hey, I'm not seeing the savings you said I would have. And then I'd go to site, roll my truck, cost to me, and I would see, oh, you installed a hot tub, so you're using more energy. So it really helps with those types of conversations. It's still the most efficient inverter on the market. So it's 99% weighted efficiency, the CEC's California Energy Commission. It's 28 pounds, so it's much lighter than our current storage inverter. And one of the biggest things that I'll get into later is we really skyrocketed the DC to AC ratio. So it's 200% DC to AC ratio. You can, on a 7.6, you can put 15.2 kilowatts DC on it. And it actually makes a lot of fiscal sense to do that when you're DC coupling with batteries. But again, I'll get into the graphs and the details in a minute. The EV charger can be connected directly to the inverter. So again, we're saving that breaker space. The EV charger is a smart EV charger, so it's controlled through the SolarEdge app. So now your homeowner can see their home consumption, they can see their inverter production, they can see what their car is doing, charge and discharge their car, all from one app. And then as we, again, integrate more batteries and capability, they'll be able to control all those things from one app. The smart home energy manager, they'll be able to program lights to turn on and off. They can, if we think about smart devices now, we think about Google. My home is Google enabled, Alexa, and I say, Google, turn on my lights, and it's a convenience item. It's a glorified clapper. But when SolarEdge thinks about smart devices, we really think about, well, how much energy is it saving? Are you producing extra energy so it makes sense to turn on a fan, or to cool your house a little bit colder, like pre-cool your house before the time of use rate hits on, or you're producing extra energy, so let's superheat your hot water in your hot water tank? That's how SolarEdge thinks of smart energy devices. So the Energy Hub inverter not only has unmatched performance because it's the most efficient inverter in the market, it's very scalable and a backup capability. So we've also launched a new product called the backup interface, and the backup interface allows you to connect up to 3 inverters while in backup. Those inverters can have solar, they can have battery, they can have solar only or battery only, or they can have both. It really comes down to the use case and what you guys want to do with it, but you have the ultimate in flexibility. You can choose to back up an entire house, or you can choose to back up just a sub panel. It's up to you. It's an easier installation because there's fewer components. The auto transformer, the consumption meter are built into the backup interface. The backup interface has a generator input, so we'll get into the details of the backup interface, but I'm really excited. This is a product I've been designing for the last year, and I'm excited that it's finally out. So again, 200 amps, basically the backup interface is a transfer switch, right? And so when the grid goes down, the backup interface islands the home and allows it to run in backup in parallel with the grid. I've been calling it a nano grid. The max continuous output for an inverter is 80% of the AC rating of the inverter. So if we have just batteries, it's going to be 5 kilowatts per battery. But if you have battery and PV, then you get 80% of the AC rating. So if you have a 7.6 kilowatt inverter, that's roughly 6,080 watts. So you'll be able to get 6 kilowatts in backup continuous. The system efficiency with the HD Wave inverter is at 93.1%. Again, it's just a much more efficient inverter. The DC to oversizing, again, like we talked about, is 200%, and the ease of installation is just a little bit easier to install, especially if your utility required a production meter. It's just a little bit easier to install. So let's go through the Energy Hub benefits and how we get you more energy, how it's simple to install. We'll talk a little bit about safety, and then visibility and integration. So higher efficiency. SolarEdge still strongly believes in DC coupling. DC coupling has changed. When we were DC coupling 20 years ago, we were connecting solar panels, 12-volt solar panels to 12-volt batteries, and we'd have a charge controller, and it was difficult to do. There was a lot of wasted energy. It wasn't very efficient. But the idea still remains the same. The principle is I want to go from a DC source to a DC source. So that means the inversion doesn't take place, and it remains the highest efficient system available. So SolarEdge, we've partnered with LG Chem and the Resu 10H. It's a fantastic battery. It's lithium ion. It's got a great power density. It's 9.8 kilowatt hours of energy, so roughly 10 kWh. When we DC couple with that system, with that battery, we can go directly from 400 volts on the roof to 400 volts into the battery. There's no inversion process. So the only deficiencies we experience are the charge deficiencies of the battery. So once it hits the battery and then it discharges to the inverter makes it AC, and that's where the biggest loss is DC to AC. And again, SolarEdge is 99% efficient. It's a really efficient product. So your system efficiency, that includes the charge and discharge efficiencies of the battery, the efficiency of the inverter, and the efficiency of the optimizers, is 91.6%. If we look at a AC coupled system, even with a great SolarEdge inverter, because you go from solar DC to AC, and then you have to go back to DC when you put it in a battery, you go DC to or AC to DC, and then when you want to use that energy, you have to use it again, DC back to AC. That's 3 conversion losses, and that system really is 87.6% efficient. So even with a great SolarEdge inverter with an AC coupled battery, and well, we can call this any AC coupled battery, whether it be a Powerwall or Sonin or whatever, you're going to see that the system efficiency just suffers. So what does that mean to the homeowner and to the end user? Less energy. You lose a lot more energy when you have these efficiency losses. So if you want to maintain more energy during backup, then the best way to do it is increase your efficiency. So I talked a little bit about 200% DC oversizing and why. I come from the old school where we were like, solar panels are super expensive. I never want to oversize more than 110%. But now I fully advocate, high DC to AC ratio, because we're never going to see, full production. So why is 200% allowed? So SolarEdge on our Energy hub inverter, we allow 200% if there's a battery connected. Well, because the battery is DC coupled, we think about clipped energy. So it's not just raising the shoulders anymore. Any of this clipped energy does not go through the inverter. It just goes directly into the battery because it's DC coupled. So in this example right here, we can see the 7.6 line. That's the inverter classification, we'll say 7.6. And the battery has a max charge capability of 5 kilowatts. So 7.6 plus 5 is 12.6 kilowatts, right? So any of this clipped energy goes directly into the battery and you don't lose any of that energy, which is amazing, right? If we compare that to a traditional AC coupled system, all that energy is lost because, again, you have to invert that energy to use it, right? So this is the biggest reason why I like DC coupled, because as a solar installer, I make most of my money on the roof, right? So if I can go with a higher DC to AC ratio, I can install more solar panels on a roof. That system will work much better during a grid outage during the day, even if it's low light, there's snow all over. Well, if there's snow all over the panels, there's not a whole lot we can do. But there's snow everywhere, hopefully not on the panels. You can still really charge your battery and power your home with the high DC-to-AC ratio. Safety is always near and dear to my heart. SolarEdge, our optimizers operate underneath every single solar panel. So when you shut down the inverter or the system, the optimizers go to safe DC mode. So that's 1 volt per optimizer in series. So if you have 20 modules in series, that's 20 volts. What we decided to do is, this was our main infrastructure for all rapid shutdown capabilities, whether it's residential or commercial. And what we decided to do for Energy Hub and HD Wave is you can install an emergency stop button. So if you need to install emergency stop button, let's say the inverter is in the basement, you can install that emergency stop button outside next to the main service panel. Firefighter, first responder hits the button. Now the system is rapid shutdown. It shuts down the battery as well as all of the optimizers. So it's completely safe. Full visibility and control. So previously to our battery customers or storage customers, we wanted to make sure that the installer had the most control. And the reason we lobbied for that, or I decided that, was I did not want a homeowner to change a time of use profile that the installer had set. Let's say is I want to discharge my battery during on-peak times and mess with the incentive or payback structure that the installer represented. Because if we give homeowners most of the control, then again, I didn't want to be in the middle of that conversation. Oh, well, the homeowner changed their battery reserve to 75%. And so now the payback does not make any sense at all. What's happening now is a lot of people, myself included, think, okay, well, I'm a homeowner. I paid $5,000 for this battery. It's my asset. I want to be able to control it. So we did. We've launched a new app called My SolarEdge. So again, the installer is going to be responsible for creating the time of use profile. But with My SolarEdge, the homeowner now has the ability to put the inverter into backup mode if they need to. We'll send push notifications that says, hey, there's a severe weather event coming. We recommend you go into backup mode. And so the homeowner will then prioritize charging the battery to make sure it's ready for the backup event. If you're in California, then we also do the same thing for the PG&E fire shutoffs. We call them fire safety shutoffs. But basically they shut down power, and if there's a high wind event, so we don't catch California on fire again. All of our connected devices for Energy Hub range from CTs for import and export to EV charger capability. So previously for our EV charging inverter, you connected a cable directly to the bottom of the inverter. That's a little bit different now. Now we have a standalone EV charger box and kit that is hardwired 2 or 3 wires, line 1, line 2, and ground, to the inverter. The reason for this is many people did not want to have to put the inverter in the garage. They either wanted it outside where it was accessible, or maybe in the basement or something. So they wanted this device, this kind of remote standalone unit that they could put wires and conduit or whatever to transition between inside and outside or into a different location. So that's what that does. Again, we have our LG Chem battery with our backup interface and then our smart devices. So we have a hot water heater, we have some smart outlets, we have a relay. So the relay is important for load shedding when you're in backup. So the relay is just a 20 amp relay. And when you go into backup mode, you can tell the relay, I want you to open up the thermostat line, which turns off the HVAC system, because you don't want to drain your battery air conditioning your entire house if you don't need to, right? So the EV charger, again, is a little bit different. As you can see in this photo down here, this is a 6x6 inch gutter. Anytime you're installing the Energy Hub with a backup interface in any of the ancillary devices and batteries, I strongly recommend you use a gutter. The gutter will really help with your transitions between walls. So if you have to go outside a basement or a wall, and then all the stuff for the backup interface, all the conduit entries for the backup interface and then the Energy Hub are bottom entry. So it really helps with all your installation looking clean, really helps with all your conduit work. So just trust me when I say plan on buying a 6 inch by 6 inch by 6 foot gutter, and that will cover any of your installation. It's the easiest thing to do. The EV charger itself has the best warranty out of any EV charger on the market. So it's a 5-year standard 5-year warranty versus our competitors typically do 2 to 4 years. We can empirically show that the car charges from sunshine only, and we do that through our app. It's a level 2 charger, so you can charge the car with a continuous 40 amp charge. Also, what's interesting about this, and I've tested 3 times, is now we can charge the car in backup. So on one of my test sites in Santa Cruz, he has a Honda Clarity. We turned off the grid and we went into backup mode, and we successfully charged his car and powered his entire house while in backup. So just clean sunshine charging that car, nothing else. It was fantastic to be able to see, like, he knows when the grid goes out because of fire, whatever, I can still use my car and get around town. CTs, again, for consumption mode. What I really like about the CTs is, again, it takes away those really tricky conversations when homeowners start to use more energy after they get their PV system. You can use our standard split core CTs. We also allow for Rogowski coils or a flexible rope CT. There's no more requirement for the conditioning circuit on the Rogowski coils. You can buy our newer CTs that don't require the conditioning circuit, but it still does require 12-volt power supply. So the 12-volt power supply, usually, you can put one inside the gutter I was talking about. You can install a small J-box with power supply. It's fairly simple and straightforward, but split core CTs can usually get you all the way. All right, I'm running out of time, so I'm gonna, oh no, I'm good. All right, so flexible backup interface. Let's talk about the backup interface. Again, this is my brain candy, so I'm really proud of it. When we talked about backup before, we had our SolarEdge inverter, and we had to launch the storage inverter, and the transfer switch was located inside the DC disconnect. So you only got 21 amps of backup capability, and by routing everything through the inverter, it was ingenious in the fact that it was easy to install, but that means we could only do small loads. Like, we couldn't do a lot of big loads for backup. So the overwhelming response was, I want whole home capability. And even if I'm not going to use whole home backup, I want the ability to do whole home backup. So that's what the backup interface does. It allows you to have the ability to do full home backup, no separate main service or main distribution panels required. Home wiring is super easy. The energy meter, the consumption meter, and the auto transformer are built into the backup interface. It's a 5 kilowatt auto transformer, so now it provides more phase and balance capability while in backup. So this is what the backup interface looks like. As you can see, we have two variants. We have one that looks like this, and it has a 200 amp main circuit breaker. It's UL listed and certified as a service entrance. So if you're coming directly from a meter only and hitting the backup interface, there's a bonding jumper for your ground and neutral conductors, so you can make it a service rated connection point. Also in here, you can see on the DIN rail, there's a DIN rail that has comes factory installed with one 2-pole 40 amp breaker. You can add up to 2 more breakers. You can change the breaker to a 60 amp breaker when we get to the 11.4, but that's where all your solar breakers are going to land. Each inverter again has the capability of having 80% of its AC rated power in backup mode if it's coupled with a battery and with solar. So what that means is with the 11.4, you can get around 9 kilowatts, it looks like. So if you had 3 of those, that's 27 kilowatts of solar and battery just in backup. And then with 2 batteries per inverter, you can get 60 kilowatt hours of storage. Also integrated into the backup interface is a generator input. You can connect up to a 15 kilowatt generator directly to the backup interface, and we'll be able to control that generator. So we went from storage inverter, which had a small like 60 amp, 100 amp sub panel with 4 or 5 circuits in it, to backup interface, which really allows you to do whole home backup. You can, if you have an existing storage inverter on site, you can still connect that to the backup interface and still take all the other capabilities of backup interface, like generator input and all of those things, but you can only do 1 inverter if you're going to do the StoraEdge today. If you use Energy Hub becomes a grid forming inverter that allows other inverters to sync their sine waves to it. So that's huge. That means eventually you will be able to connect existing sites. So if you have an existing SolarEdge inverter and you can come out with an Energy Hub, a battery, and a backup interface, you can AC couple. Now, again, I personally like DC coupling, and I may consider just swapping the inverter out, but let's say you didn't do that original inverter, so you don't want to touch the work. Great. Leave that existing installation, add the Energy Hub and the backup interface, and now you can connect a generator to it. So it's flexible, it's scalable. Again, you can have 1, 2, or 3 inverters. You can add an EV to it. It supports generator connections. I'm going to use the words easy and fast very loosely. And the reason I do that is because if you have a home that has a combined meter main, they're very common on the West Coast. It's a little bit trickier, but if you're on the East Coast, then your meter is typically separate from your main distribution panel, so the installation is relatively easy. So let's talk about the different service entrance styles. So we're going to say complete home backup. So in this example, we have a meter that is separate from the main distribution panel, and so you basically just reroute those wires to the backup interface and then backup interface to the main distribution panel. So I was able to do this on a couple of installations where there was a J-box relatively close to the meter, and we were able to just say, okay, we pulled back the feeders that went to the main distribution panel after removing the meter from site. So we pulled back the feeders to the main distribution panel, we installed the backup interface, and then rerouted those same exact conductors to the backup interface, and then ran new conductors from the backup interface to the meter. So it was very easy to install. It took us about 4 hours on site to do that work. But now the homeowner had whole home backup. If your main service panel looks like this, where the meter is integrated into it, again, that's very common on the West Coast. You can do whole home backup. It may require you to install a new backup loads panel and move all of the loads from the main service panel to a backup loads panel. So that type of work is extensive, and it's almost like doing a main panel upgrade. So you should bid it as such, but you can get whole home backup. And again, that's what a lot of people are asking for. What I did on my house is I did partial home backup. So I have a very similar meter setup where, again, it's integrated into the main panel, and I moved over all of my small loads. So my 15, 20 amp breakers, my 30 amp breakers I moved over. The only load that is not backed up is my air conditioner. And again, the reason I did that is because I didn't want the air conditioner to completely discharge my system if I'm not home. So, because I don't have the relay yet. So partial home backup is still a very viable option, especially with all the generator support and things that we offer. So talking about generator support, there's 3 modes of operation. One is called convenience. In convenience mode, just prioritizing having as much energy as you can at all times. So that way, if the sump pump kicks on, if you have a well pump on site, you have immediate power and your life is not interrupted in any way, shape, or form. On the opposite end of the spectrum, we have fuel saver mode. And fuel saver mode basically says, okay, I'm going to use my solar and my batteries. I'm going to prioritize using those. And the generator is only going to kick on when I hit high consumption. So my sump pump is running or my air conditioner turned on or something like that. And then there's something in between, and we call it battery mode. So we prioritize using solar and batteries, and we run the generator at a low spin rate, so conserving fuel on the generator. And we will power the home using solar batteries. As the batteries maybe get depleted, we can charge them with the generator. As the generator is, again, maintaining a low spin rate, if we need to keep that spin rate around 50%, we'll charge the batteries with the generator. So it's kind of a hybrid between the two and a more dynamic mode of operation. All right, I think that puts me at time. Thank you so much for coming out with me this morning. If you have any questions, let's go ahead and throw them into the chat box. I think I should have some assigned to me, so let me look at those. There they are. Pop out that question window. Okay. So the question is, my company sells a lot of Tesla Powerwalls. You know, how does this new SolarEdge technology integrate with the Tesla Gateway? That's a great question. So Energy Hub with the Tesla Gateway still is going to work great, because not only does it have a production meter, it has a import-export meter, which if you have a special requirement like zero export or something like that with the import-export meter, then you don't have another box or another meter to install. So when you're using a Tesla Gateway and there's kind of 3 modes of operation. So the Tesla Gateway acts a lot like the backup interface. And with the Tesla Gateway, you're going to have in your backup panel, you're going to put your battery breaker and you're going to put your solar breaker. Now, if you do that and the breakers exceed the 120% rule rating of that panel, then you have to create a generation panel. And a generation panel is just another panel, but you put all your generation devices in there. So if you have multiple batteries or another solar inverter, that goes into the generation panel. But again, we still really have to worry about that 120% rule. Now, because SolarEdge has all that integrated into the backup interface, we don't suffer the same kind of requirements that the Tesla Gateway does. So if you're using a Tesla Gateway, great. It's a fantastic product. I'm a fan of it. All you have to do is use your PV inverter like you normally would. You're going to install the PV inverter into either the backup panel or the generation panel. When is Energy Hub available to purchase? Oh, that's a great question. It is on your price list now. So talk to your distributor, CED. They have it on their price list. You can purchase it today, or they can take orders for it today. And I can click the slide back one more time. It'll just cost you $5. I'm just kidding. Cool. So this was, again, generator mode. So on the East Coast, there's a lot of already installed generators. You know, it's requirement for all the hurricanes and snowstorms you guys get out there. I'm in California, which is why it was really dark when I started my presentation. So it's 6:30 a.m. for me. Oh, sweet. I have until 10. Oh man, I thought I had until 7. Oh, we have loads of time. Cool. Okay. Well, that's awesome. Let's get into our online designer. I can do a live demo of our online designer real fast. That's great. That's great news. Oops. All right. Man, I was flying through that because I thought I only had an hour. I feel bad now because I was talking fast. All right. So that was the Energy Hub, our new product. I'm really excited about it, as probably you could tell. A lot of blood, sweat, and tears went into the backup interface. So I'm proud that that's finally launched. If you've never used our online designer, we have a design tool, and it's free. It's pretty amazing. If you haven't checked it out, you should totally do that, and watch. It's gonna kick me out for some weird reason. Live demos are always difficult to do because you just never know what's going to happen. So just log in. I should probably show you how to get there, huh? All right, so if you go to SolarEdge.com and if you've never used our designer before, you just click on the login button, and then you can go down to designer. So the designer is a free web-based design tool. So there's no more compatibility issues with Mac or PC. It's just online. And so we're going to run through a live demonstration right now. So all these projects are all projects that a SolarEdge employee has made. So we all work for SolarEdge. So we're a global company. You see designs from Italy, Ireland, Japan, Germany. You see designs from all over the world. Why it's important for you guys, you installers, is you're going to be able to see the designs that your colleagues make, and you'll be able to on the fly edit. If you're an installer out in the field, you can say, oh, this panel didn't fit on this roof, so I'm going to move it over to this other roof and change the as-built as you go using your phone, using the Site Mapper app on your phone. But I'm going to just create a new site. Now to create a new site, you just click the plus button down on the bottom right-hand side of the screen. Now, there's a basic version of Designer, and I'm going to click that first, because overwhelmingly, again, a lot of people said, I love your design tool, but I don't want to have to create a whole design just to know which optimizers I need to use, right? So that's what the basic version does. It's just an optimizer pairing guide. So you can type in something, SolarEdge training test cam, fantastic. We're gonna say this is in, we'll say it's Boston, Mass. Cool. I don't even have to I could put a zip code. I don't have to put in a full address. You can put in a full address if you want to. I can say what type of solar panels I'm using. Let's say, sweet, Hyundai sounds reasonable, and we'll say 295. I'm worried that I picked like just a random weird panel that doesn't match anything, but we'll say that there's 22 modules on site for 6.49 kilowatts peak. It's flush mounted. It's 180-degree true south, fantastic. I'm going to look at my inverter, so I click on calculate, and at 125% DC-DC ratio, it's recommending the 6,000 watt inverter, and these are all of the compatible optimizers, the P370, 400, 405, 485, and the 505. So any one of those optimizers are compatible with that specific solar panel. So that's the basic version. You can create this report and say, yep, I'm going to have 2 strings of 11 solar panels using these optimizers. And that's just one way really quickly to say what optimizers work with this solar panel. Let's change the panel real fast and see if we can get a different result. Let's go to LG. Oops, of course you can't find that. And let's go to the 390 neon, I think. 370? Yeah, 370 neon R. Great. So I'm going to recalculate. So since I changed the solar panel, I have to click recalculate. And now the optimizer selection is only one. It's saying I am only able to use the P505 with this solar panel in this region. Okay. So let me go back. You can turn that basic configuration into an actual design, and I should have showed you how to do that, but that's okay. I want to click a residential design. Cool. And we're going to do CED webinar. Cool. And I want to pick this house in my house in Phoenix, Arizona. All right. So the first step when you're doing a full design is to type in the address, just as you saw. It's powered by Google, so click on the recommended address, and it's pretty accurate. It gets you to where you need to go. If the house you're trying to design does not fit within this blue box, you can zoom out, or the building, I should say. It's only a problem with usually commercial buildings. Zoom out, and you'll be able to put the entire building on your canvas. You can, let's say the address that I typed in yielded the wrong result and the pin needed to be moved over here. I could totally design this house and drop my pin somewhere else. But I like designing this house because there's a couple things that we can do. Okay. Actually, maybe we should design this house. Should we try to design this house? All right, let's try to design this house. It's not my house. It's fine. We'll try to design that one. All right, because I think there's another feature that I can highlight with that design. Okay, as I scroll down, you can see you can enter the customer's information. Sure, it's got my name. Is it a residential or commercial building? I can type in the annual consumption. Let's say I use, 1,000 kilowatt hours a month, so 12,000 kilowatt hours annually. I can add a consumption profile, so that just says it's very typical of how I use my energy. So I am a family with an infant or preschool children. So I use a lot of energy in the morning, a little bit less at night, and then a lot of energy at night. So that would be my specific. But if, let's say, I was a single or 2-person household, yeah, notice how that consumption during the midday changes, right? So I'm going to do that. Okay. I can set an export limit if there is one, but generally there isn't. So I'm going to just click create. So this creates the site and drops it on the canvas. And I'm going to be able to basically just draw around the outside of the building. Oh boy. I always get scared when my my wheel spins for a long time. All right, so we have to remember that homes are typically built with 90-degree angles, right? And we have to remember that this is an image from space, from a satellite. So if we were directly over the house, I should not be able to see this wall, but I can see that wall. So as you're drawing around the outside of the house, I'm always going to remind you to take some time and just make sure you have 90-degree angles, because that's how houses are built. So I can start by drawing the outside edges of the roof. So I'm going to go ahead and start that by left clicking and then just drawing around the outside edge of the roof. You will see a 90-degree angle pop up when I have achieved a 90-degree angle. So I'm going to do that. And there, looks good. So even though it looks like I'm going off the front of the house, that's fine. I can move that line later. I just want to make sure I'm getting these 90-degree angles. All right. So we have this inner edge tool. So I've drawn all the outside edges. I'm curious to see. This inner edge tool works sometimes. I'm curious to see what it's going to do. So what the inner edge tool does is it looks at the polygon that is the outside and then tries to fill in the blanks. Sometimes it works great, sometimes not at all. So I'm going to click this inner edge tool and see what it does. We may break it, I don't know. Ah, pretty good. Oh my gosh, it did pretty good. Relatively close. It missed kind of this this hip and it missed that line. So I'm going to Control Z and undo that and draw all my own inner edges. Okay, so I'm going to start with this one. That's just the ridge line. This center line. And it does get better every time a user inputs. So I was really hoping that would work. I'm kind of sad it didn't. Great. Okay. So now we have our roof line drawn. You can see dynamic the distance of those roof pitches and surfaces. Okay. I'm going to add the obstacles. We can see a whole bunch of little attic vents right here. So I'm just going to left click and drag the obstacle tool over those. So when I get to laying solar panels, it knows that it can't put a solar panel in that region. Great. Okay. So then I'm going to click the 3D button. And we basically made a two-dimensional surface, right? So with the 3D button, I can now left click and drag the ridge line. And now I have a three-dimensional house. I can change my roof pitch. I can say, oh, it's really a 512. Or I can say, well, this one's actually a 412, so I'm gonna put 412. So we don't have to worry about snow in Arizona. The vents, I can double click them and make them flush with the roof. Because those are, the special integrated roof vents. So I'm gonna do that. But this may be a vent stack, so I can make that a little bit taller. This may be a vent stack, so I'm gonna make that a little bit taller. Great. All right, so now I have a 3D image of what this house looks like. And isn't that pretty? Fantastic. Okay, now that my design is done, I'm going to get into module placement. And I'm going to left click on the roof surface to place modules on that surface. So I'm going to click the add module button. And then I'm going to write down some LG electronics and let's do the 320s. 340s, 320s. Cool. Sure, they can color it blue. It's flush mounted. The azimuth is based on the roof that I drew, so it's 270 degrees. These modules are going to be installed in portrait. I'm going to have 1 inch of column spacing and 1 inch of row spacing. Fantastic. So now, once that's done, I just left click and drag, and it automatically puts modules on the canvas for me. Now, some of you are like, oh, you have to worry about walking lanes. That's true. So in Arizona, for the ridge line, it's 1.5 feet on either side or 3 feet in one direction. So I'm just going to do 1.5 feet on either side. Oh, that's 2 feet. Fantastic. 1 foot 6 inches. All right. Great. And then on the to walk up, they need 3 feet. So I'm going to add this line right here. All right. So all this is a guide. It's a recommendation. So I can grab the group of modules and try to get them into place. It looks like I might lose 1 or 2 modules. Looks like I'm gonna lose that one. Because I'm not mounting any solar panels here, I don't have to worry about that, but I wonder if I can get 1 more panel over on the other side. So let's just go ahead and add another solar panel. Sweet. So I don't know how many of you would actually put this extra panel there, but you know, we're trying to install as many panels as we can, right? So now let's put some panels on the other roof surface, which is right here, and it's going to remember the panels that I selected before. And it looks like I might be able to get 1 in landscape down there. So let's see if I can do that. So to do that, just click the landscape button. Not quite. I can get it. Okay, great. And I might be able to, let's draw my walking lane, 3 feet. Great. And then I might be able to get 1 or 2 more panels on this roof surface. Let's see. If we had a 1.5 foot walking lane here, and again, the justification, like I want face panels on the north side. So the justification, I think in the new California code says that if you define an access point, which would be the other side of this roof, then you don't have to worry about the 3 foot walking lane on this side. Okay. Some of you are like, what are walking lanes? Man, this poor array is just all segmented and sad and lonely. All right. Entire site. Let's see, we've got 18 solar panels on this house. It wouldn't be a fun install, that's for sure, but we could do it. All right, so that's the design we're gonna go with. 18 panels. It looks like it's DC peak is 5.76 kilowatts, and the estimated energy production is 10 megawatt hours annually versus the consumption that we identified, which is 12. So it's going to cover, 80% of the homeowner's consumption. All right, let's get into the electrical design. So the reason we have the basic version of Designer is because of this. So with the full design, you'd have to draw the house and all those things, and people are like, I don't want to do that. I just want to know what optimizers to use. So that's why we have the basic version of Designer. So the Designer is already recommending a 5,000 watt inverter. The oversizing is 110%. So I can change the oversizing allowed to 155%, and now it's recommending a different inverter, a 3800. Fantastic. That's a 20 amp breaker. If they have a small 100 amp panel, that's super easy to do. The optimizers that are recommended are the 320, but if no 320s were available, I can install the 340, 370, or 405. So I'm just going to click generate on the 320. And now the tool is asking me to string the solar panels, but we have a feature. It says auto string. I'm going to click that and see if it's going to give me 1 string. Boom, it does. 1 string. So it tied all of these solar panels together on 1 string of 18 panels. and click generate. Fantastic. All right. So now my design is done. I can click on Summary and Reports. And Summary and Reports gives me the design, the estimated production, all of those things. Sweet. So in this image, I can zoom in and out till I see the image that I want to see. It's kind of cool. I usually like to, show off the 3D rendering. I can look at the report. So the installed capacity is 5.76 kilowatt peak. Annual energy is 9.7 megawatt hours. Here's the amount of clipping I'm going to see. Total clipped energy is 2.25%. So that's without any snow or shading or soiling losses. Well, the loss chart is down here. You can change these estimates as you see fit. You can enter more for snow if you think that's going to be a problem. So with that in mind, 2.25%. So that system's not going to clip after 6 years because you lose 0.5% every year, 1% every 2 years. So awesome. After 6 years, that system's not going to clip anymore. And it'll still be fully operational. And as those modules degrade, because they have optimizers, it'll work great over the lifetime of the system. Great. So if I wanted to add a battery, so look at the consumption here. So the amount of self-consumption, so that's the estimated energy that the home will use during daylight hours, because we have no batteries attached, is 12. If the annual consumption is 12 megawatt hours, self-consumption is 44%, so 5.31 megawatt hours. This doesn't include export. So if we look at this graph, we can see, okay, my home is going to use, of the energy I created, 44% of it, I'm going to export 45% of that. So if you have net metering, great. Use the grid as a battery. But if you don't have net metering, or you want the battery capabilities, you can very easily edit that. So yeah, let's just edit the design real fast because I've got like 3 more minutes. So I can select my inverter, and then I can say, I want to edit this inverter. Cool. And I'm going to change it to a battery inverter. See the little battery icon? Fantastic. And we're going to put an LG Chem Resi on it, and we're just going to do, why not? We're going to do 2 batteries because we can. Uh-oh, my stringing changed because the old storage inverter, shoot, the old storage inverter does not allow 5,700 watt string. It only allows 5,250, so I'm 1 solar panel over. So we're gonna drop a solar panel for this comparison. That sucks. I thought it was gonna be easy. That one lonely island solar panel. And now my stringing is good because I'm under 5,250 watts on this specific inverter. And even though we lost a solar panel, I imagine that we're going to see that the self-consumption is going to increase because I can use the energy that I generate stored in a battery and use it later. See, self-consumption went up to 98%. So all of the energy I generate is being consumed. That's awesome. And then you only import 2.83 megawatts annually from the grid. And then lastly, this button down here, this allows you to export the drawing and the site information to the monitoring portal. So when you do that, it creates the site in your site list. And when the installers go to do the installation, if they download the app Site Mapper, they can scan the QR codes of the optimizers, but the map is already done for them. right? So it's a really easy way to streamline the tool. And then if they need to move the modules while they're on site, they can. They just use Sitemapper and say, oh, I had to do a row of 5 instead of a row of 4 because this module didn't fit over there or something like that. So they can dynamically change and edit those things while on site, and that will reflect back into here. All right, that brings me to the top of the hour. There's a couple questions that did come over, so I'm going to try to answer them really quickly. Does the Energy Hub HD Wave inverter now have built-in Wi-Fi, or do we still have to use your gateway set? That's a great question. It's a two-part answer. So I'm going to say it does have built-in Wi-Fi, except for the Wi-Fi that we do is for connecting to your phone, because there's no more screens on our inverter. So it just creates a local Wi-Fi network that your phone can connect to, that you use to program and commission the inverter. The app for that is called CED app. For communication options, we still have our cellular technology. So I believe currently cellular is LTE, so you can use your LTE card, or Zigbee gateway is an option. And then pretty soon we're going to be announcing a new communication device, and it's going to be Wi-Fi based, but it's not going to be open network Wi-Fi that you're thinking of. The reason for that is in rest of world, we offer Wi-Fi devices, and it's the #1 headache to our installers there, because homeowners inevitably change their passwords. They don't pay for their internet. They change providers maybe, and then you lose communications to the inverter, and it's a truck roll for you every time. So we never launched a Wi-Fi product in the US because it is a headache. So we have other devices that will have a closed garden Wi-Fi network eventually. Is there best way to get a summary of everything? Not quite sure I understand the question, but let me take a stab at it. If we're talking about a summary of the designer, sure, just click the summary reports after you finish the design. If you're talking about the summary of the presentation and everything I did today, yeah, we'll send that out at the end. So I'll send my presentation to CED and they can disperse it. Are there any requirements for the generator? Can be cheap portable type. Yeah, so you can install a cheap portable generator. So what I did on my house is I just wired a 240 volt outlet to the generator input, knowing that if I need to go pick up a cheap Coleman, generator or something I pick up from the Home Depot, I can just plug that thing into the wall. So that's one way to just ready your customer's house for generator supply. Of course, if you're using a cheap portable generator like that, there's not going to be any of the dynamic control to wire auto start stop. It's going to be heavily user dependent. So just keep that in mind. How long is the subscription for the cellular service? What happens after that subscription ends? So we offer 2 data plans. One is 5 years and the other is 12 years. So the subscription is not a monthly subscription, it's just the cost of the card, and you get 5 years of data or 12 years of data with the cost of the card. With our Energy Hub inverter, I think with Energy Hub, it actually might be factory installed. You might already have, I think it comes with the cost of the Energy Hub. Let me double check that. I'll get back to you on that one. But anyway, it's a 5 or 12 year plan. We notify you at 4 years. We say, hey, your data is going to run out this year. You can re-up or you can choose not to. Sometimes what we're facing right now with our cellular cards that were CDMA or GSM technology, if that technology doesn't exist, there's not a whole lot we can do about it. So we'll send you, let's say, for whatever reason, LTE is gone in 6 years and you bought a 12-year card. So at year 6, we'll provide you the hardware for the 5G technology or whatever it is at that time. Say, okay, you still have 6 years of data left. Here's the card so you can get this inverter communicating again. So that goes out. If I Google SolarEdge Energy Hub, nothing relevant comes up. Where can I find info about my Energy Hub and share it with the team? That's a great question. So let's go to solaredge.com, and if we just go to products, and I'm going to go to SolarEdge. And the data sheet should have been here on Tuesday. Oh, I've got to make sure I'm okay. Good. Keep my fingers crossed. Oh, come on. There it is. SolarEdge single phase. That's SolarEdge. Let's see if it's in. It should have been here Tuesday. I'm really sad that it's not. Products. Nope. All right. I'll send you out. I'll include it with my presentation. I'll send out a data sheet for you. Is the new hardware going to be free of cost? Oh man, that's a good question to work out with CED, the pricing structure. Our aim is to make it the same amount as the storage inverter today, or maybe a little bit less, but that's for you and CED to talk about. Cool. All right. I think cellular is pretty awesome. The reason I like cellular is because I don't have to roll a truck. I don't have to, every time my homeowner changes their network ID from password from QKittens 2 to QKittens 3, I don't have to go to site. I don't have to hear about it. So I grew up in Arizona and did a lot of installation in Arizona. And every time my snowbirds left for the summer, I was getting tons and tons of phone calls about their systems being offline and not communicating. And so I'd roll a truck and yeah, system's working great. And they just turn off their internet when they leave and they forget. So cellular, I didn't have to worry about that. I always had communications with the system. And then that way I knew like, oh, this Mr. Jones's inverter did go down, right? And I could address that. Free built-in is Ethernet. So if you don't want to do a paid wireless device like cellular or Zigbee gateway or closed garden Wi-Fi, we do offer Ethernet, and that is free. Yeah. The question is like, what if the hardware runs out? Like we paid for a 12-year data plan. Sorry. So there was a question like, what about the 12-year data plan and it ends at year 6 and you have to send me new hardware? Yeah, we send that to you for free because you paid for 12 years. Yeah, we're gonna keep you whole. We're not gonna say, oh yeah, sorry, that sucks for you. That's not what we do. We'll give you the hardware to get communications back up and running and